Hello students, now we are going to see the definition of binomial distribution, its moment generating function, mean and variance. The definition is given as follows. A random variable x is said to follow binomial distribution if its probability mass function, simply we call it as PMF, is given by probability of x equal to ncx p to the power x q to the power n minus x, comma x ranges from 0 to n, and p plus q equal to 1. Here p denotes the probability of success, q denotes the probability of failure, n denotes the number of trials, and x is the number of successes. Here the sum of probability of success and probability of failure is equal to 1. Now we see the moment generating function. For the binomial distribution, we can call it as MGF. Since the binomial distribution is a discrete type problem, the moment generating function formula is given by m of t for the random variable x equal to sigma e power tx probability of x for all the values of x, which is defined in the definition. In our problem, x ranges from 0 to n e power tx. Our probability mass function is ncx p power x q power n minus x. Now we have to simplify the expression. Here in this expression we have e power tx and p power x. These two terms have the same power x, so we combine it, p e power t whole power x. Then the another term q to the power n minus. Simplifying the above expression, put x equal to 0 to n. If we put x equal to 0, we get nc 0, p e to the power t power 0, q power n minus 0. Put x equal to 1, we get nc 1, p e power t power 1, q to the power n minus 1. We put x equal to 2, nc2 p e power t power 2, q power n minus 2, and so on. If we put n x equal to n, we get ncn p e power t power n q power n minus. Further simplifying this, we know that the value of nc0 is equal to 1 and p e power t whole power 0 equal to 1. Finally we get q to the power n plus nc1 p e power t power 1 q power n minus 1 plus nc2 p e power t power 2 q power n minus 2, etc. In the last term we have ncn equal to 1, p e to the power n, and q power n minus n, that is q power 0, that is also. We know the formula a plus b power n equal to a power n plus nc1 a power n minus 1 into b plus nc2 a to the power n minus 2 into b power 2 plus etc. up to plus b power n. So if we are applying this formula in the above expression, we get q plus p e power t whole power n. This is the moment generating function for the random variable x. From the moment generating function, we can find the mean and variance by differentiating it. Since the name itself moment generating function, we can generate all the moments from the obtained result. Differentiating this moment generating function with respect to the t, we get n q plus p e power t whole power n minus 1 into p e power t. Again differentiating this with respect to t, we get d square by dt square m of t equal to, here we have n and p is a constant, we take it out, and we have q plus p e power t power n minus 1 and e power t, the two terms, product of two terms containing the variable t. We can apply UV method, keeping the first term as it is q plus p e power t power n minus 1, differentiation of e power t is e power t, plus keeping the second term as it is, differentiation of the first term n minus 1 into q plus p e power t power n minus 2 into p e power. Now the first order moment, that is mean expectation of x, can be obtained by substituting t equal to 0 in the above. Now, mean expectation of x is nothing but d by dt m of t, here put t equal to 0, n into q plus p e power 0 is equal to 1, so q plus p power n minus 1 into p. Finally, this q plus p also equal to 1, so we get n into p. By the definition, probability of success plus probability of failure equal to 1. So therefore, this term becomes 1, and the remaining term n into p will be there. By substituting t equal to 0 in the second derivative, we get np q plus p power t power n minus 1. If you put t equal to 0, that is equal to 1, plus n minus 1 into p. By simplifying this, we get np plus n square p square minus n p square. This is expectation of x square. And we know the variance formula. Variance of x equal to expectation of x square minus expectation of x the whole square. And we have found the expectation of x square as np plus n square p square minus np square minus expectation of x np, so squaring it n square p square. Now these two terms gets cancelled. This n square p, two terms gets cancelled, and we get np as common. To take np as common, we get 1 minus p, right? And we know that p plus q equal to 1, so n minus p is equal to q. You can write this as, for the variance is np. For the binomial distribution, MGF we found, that is m of t equal to q plus p e power t whole power n, and mean, that is expectation of x equal to np, and variance of x equal to np.